Hello and welcome to the ANZ Summit for 2022 and this session, Real-World Ransom Attacks in AWS and How to Mitigate Them. My name is Richard Billington and I'm a Senior Security Consultant specialising in threat detection and incident response. But more importantly for this talk, I'm part of the AWS Customer Incident Response Team, or AWS CIRT. Now, before I jump into what AWS CIRT is, let's have a look at what we're going to cover today. And we have four main parts to our agenda. First, I'm going to talk about what AWS CIRT is and what we do. Second, I want to set the scene, both in terms of what the ransom problem is, but also why customers should care about data protection, and some of the ways that AWS can help. Third, now that the scene has been set, we'll walk through two of the more common real-world ransom scenarios in AWS, and more importantly, some of the best controls to help protect, detect, and respond to those situations. So get your notebooks out for this part. And finally, a call to action. If you leave here with nothing else, these are 5 key takeaways that each of you should go and check in your organizations. But just before we jump in, I want to check that everyone is in the right place. This is a level 200 talk. So if you've come to hear details about the low-level disk forensic techniques used to recover certain types of ransomware keys, then you're in the wrong place. This session is about common real-world attacks in AWS that we see happening far too often. And, of course, the controls to help. All right, let's jump in. So, the AWS Customer Incident Response Team, or AWS CIRT, is a team of people who specialize in incident response on AWS. We specifically focus on security events on the customer side of the shared responsibility model. For those of you not familiar with the shared responsibility model, it describes what AWS is responsible for keeping secure and what a customer is responsible for keeping secure. For example, you don't need to worry about patching an operating system if you're using Amazon S3, but you do if you're using Amazon EC2. So, AWS CIRT specializes in customer incident response on AWS. And when a customer has an active security event that they need help with, we will assist and advise that customer, normally focusing on triage, recovery, and root cause analysis of their security event. We're not here to run a customer's security event. It remains on their side of the shared responsibility model. You can think of AWS CIRT more like an additional pair of hands from AWS to help with a customer's existing incident response plans. And finally, AWS CIRT will also provide advice and recommendations focused on the longer-term strategy of trying to make sure that this event never happens again. So, how can you, as an AWS customer, reach out to AWS CIRT? Well, absolutely nothing changes in your support workflow, which is great news. Just like with any other incident, issue, problem, or request, you open a support case. Or reach out to your account team if you have one. Support, or your account team, will then engage either AWS Security or AWS CIRT if it's required. Remember, AWS support already has many service specialists, and those people already know a lot about the security of those services. Okay, time to change gears. We're here to talk about ransom attacks. So let's dive into why this is top of mind for many people, and some aspects of data protection that can help. According to Gartner, 75% of organizations will face one or more ransom events by 2025. And SecureWorks says that ransomware was the #1 threat for most organizations last year. They also see ransom demands continuing to increase. But they also said that with some good data security basics, organizations can demonstrably reduce their chance of falling victim to a ransom attack. So, at a high level, let's have a look at data protection before we jump into our ransom stories. And this slide shows 4 high-level actions you should be taking to help protect your data. These 4 will help set you well on your way towards those good data security basics that SecureWorks were talking about. Firstly, ensure you have appropriate privacy controls around your data. Secondly, set or define controls for how and where your data is used. Thirdly, manage and limit access to only appropriate people. And fourthly, ensure that appropriate encryption is used with your data. Of course, AWS has services and partners to help you achieve these four principles. We have data protection services like AWS Key Management Service, or KMS, for encryption, Amazon Macie for data discovery and compliance, Amazon Elastic Data Recovery and AWS Backup to help protect your data, and of course, AWS IAM policies and resource policies for access control. Now, we'll hear more about some of those a little later in some of our stories. AWS is also built around the idea of automation. There is no faster way to detect a misconfiguration than to have automatic detections set up. Again, we have a specific example of this in both of our stories. And finally, AWS has a network of security and consulting partners, including professional services that I'm a part of, should you need help at any stage of your cloud security journey. So, we have 4 high-level data protection aims. We have some services and automation to help. Let me put my business hat on for a second. What's in it for me? Some of those controls and services are free, but others are going to cost me money. How does it help my business? Well, funny that I should ask myself that. There are a number of business benefits. Customer information and intellectual property protection. Keeping your business data safe. Reduction of risk by automating misconfiguration detections. Reducing your business risk. And easy integration with many other AWS services, which saves time building. And finally, tools like Security Hub come with industry-standard security and compliance checks built right into them. You can turn on CIS and PCI checks with just a few clicks. Okay, it's story time. And you can tell that this isn't story time at my house. My child would have tears streaming down their face, having to suffer the injustice of brushing their teeth before reading stories. Anyway, these stories are both taken from real-world examples of events that AWS CIRT has been a part of. In fact, I personally have worked on multiple events like both of these. However, I want to make it very clear these stories are not taken from any one specific event, but rather are based on real events that we see at AWS CIRT. So, just like in the movies, these are based on real events, but with a little more pizzazz thrown in for dramatic effect. Now, because of this theatrical license, the response actions taken in these stories are also based around the recommended way to respond to these events. I'm sure many of you have heard about ransomware and the problems it can cause. In fact, I've talked about this already. However, this slide is the last time I will say ransomware, because from now on, these stories involve ransom and not actually ransomware. So, just making sure we're all on the same page. Ransom is a method that attackers use to get money, whereas ransomware is just one tool attackers can use to perform a ransom. However, as I said, there is no ransomware in either of our two stories today. I think this is an important point because when ransomware is not involved, typical preventative controls that may help stop ransomware, like endpoint protection, won't help in these two stories. Okay, our first story starts at 5 p.m. on a Friday, 2 weeks before the Easter long weekend. It involves a mission-critical database storing secret Easter Bunny chocolate recipes for the creatively named Example Corp Chocolatier Company. So, everything was humming along as normal, when John Doe, the head chocolate engineer, gets an unexpected error message after pressing the Run button to start the production run. Confused, John quickly calls Jane Doe, no relation, who for this story heads up both the IT department, database team, and security team. Jane knows how important this production run is and quickly discovers additional problem reports arriving in the queue. Jane puts on her DBA hat and examines the database itself and the related logs in CloudWatch Logs. To her dismay, she discovers that the entire database is empty, except for one row that contains a ransom note. The note was asking for payment of some Bitcoin, or else the attackers would release the data they stole. Switching hats, Jane handed the ticket off to herself in the security operations team, where she discovers a previously unseen public IP address in the database and VPC flow logs. This IP address had accessed the database a matter of minutes before the problem started. She also finds in the CloudTrail logs that the database looks like it was accidentally made public 2 weeks earlier. Now, Jane knows her company has a strict policy not to pay any ransom demands. So she dives into the logs, looking to discover whether the attacker actually did steal data or not. Thankfully, the VPC flow logs show that the data transfer volumes are nowhere near the quantity of data that was stored in the database. Having completed her initial analysis, Jane now removes the mistaken public access from the database security group and changes the compromised database credentials to prevent any further access. Finally, she knows how critical starting the production run is for example Corp Chocolatier, so she restores the database from the most recent pre-compromised backup and/or snapshot, and after checking that everything is working, informs John that he can restart the production run. Okay, now, as I said, this was an amalgamation. In reality, it would sometimes take much longer for the data loss to be detected. Database or traffic logs might not have been available. And unfortunately, sometimes there were no database backups or snapshots to recover from. Now, before we look at some of the controls that can help, let's have a look at 3 key commonalities between these events. Firstly, the database can either be an Amazon RDS database or a self-hosted database on an EC2 instance. Valid database credentials are used. This is normally via a brute force attack, which is attempting lots of different credentials, on a public database. But it can also be something like a web application vulnerability that gave the attacker visibility of the database credentials. And more often than not, no data is actually taken. It's the threat of data loss that is used for the ransom. However, that is not always the case. So, how do we try and prevent that from happening? There are many ways, but here are 3 good ones. The first is to use AWS Secrets Manager to store, access, and rotate your database credentials. If you're not using credentials that can be brute forced, that's a step in the right direction. Next is to consider using AWS IAM for authentication, rather than a traditional username and password. Lastly, and probably most importantly, if your database does not need to be publicly accessible, don't let it be publicly accessible. Turn off public access when you create it. Use security groups to limit access. Or put your database in a private subnet where it can't be accessed publicly. Let's have a quick look at how easy some of those can be. Secrets Manager is designed for the storage of database credentials, and RDS is the first option on the screen. In the RDS console, setting up a database to use IAM authentication is a simple radio button to turn on. Just make sure the database credentials get appropriately changed too. And again, in the RDS console, choosing subnets and security groups is just as easy. Plus, there's the option to turn off public access to prevent the database from getting a public IP address. Easy. But what can we do to detect issues or attacks like this? For example, if changes are made by mistake. Firstly, capturing and monitoring database logs in CloudWatch Logs or a central SIEM can help alert you to activity like brute force attacks or connections from unexpected IP addresses. Just make sure that the logs are being monitored. Secondly, we can try and detect these mistaken changes as soon as they happen using AWS Config, a service designed to monitor, audit, and respond to configuration changes in your AWS account. Specifically, the RDS Instance Public Access Check managed rule. But there are many other managed rules too. Okay, time for another screenshot. These 4 checkboxes are a section of the RDS database configuration page, and they do exactly what they say. They send the various logging options over to CloudWatch Logs for monitoring and alerting. Unfortunately, there will always be unexpected events where an attacker is able to do something you don't want them to. So being prepared and having a response plan, as well as appropriate logs available, is a critical step. The following are 2 recommendations for controls that will help you respond to and recover from a ransom event like this. Firstly, you should ensure that you have appropriate logs available. For incidents like this, that is database logs and VPC flow logs. These will help answer questions like how the attacker got access, how much data was transferred out, and also whether there were any other connections attempted by the attacker. Secondly, you need a backup. If the data is deleted, it is gone. So having the ability to restore from a functioning backup is critical for a fast recovery. Amazon RDS has backups on by default, and AWS Backup allows you to have a central backup plan for many other resource types as well. Now let's have a look at that RDS backup setting. As you can see, it's set for 1 day, so make sure you consider whether that will actually meet your production needs and change it if it won't. Okay, on to story number 2. And this time, our story starts at 7 a.m. on a Monday. Unfortunately, it's before you had a chance to get your morning coffee. And this story also involves a mission-critical data set. But this time, the data is stored in an Amazon S3 bucket belonging to any company, SLA-based Present Delivery Co. Now, you probably haven't heard of them, but this is the company that Santa Claus outsources his present delivery to. So it is a big deal. And specifically, this bucket contains all of the delivery documentation, including flight routes, naughty and nice lists, and house access notes from centuries worth of present delivery. This is critical information that has the potential to ruin the holidays for many children all around the world. Not to mention the security and privacy implications from the loss of those house access notes and naughty lists. But I'm getting ahead of myself. As I said, it's a Monday morning at 7 a.m. and one of the logistics workers, Nikki Wolf, was about to check some of those lists for a second time. You've got to check them twice. However, when she went to open the list, she only saw an error message. She quickly rang Mary Major, who was on call for the IT/security department, and notified her of the problem. Mary created a case in the company's ticketing system to track her findings and began to investigate. Before long, she discovered not only were the list files missing, but the entire bucket and everything in it had been deleted. In its place, a new Amazon S3 bucket was created with a single object, a ransom note. The note was asking for payment of some Bitcoin, or else the attackers would release the data they stole. Now, without S3 data events, she had to rely on cost and usage reports to make a guess at whether the attacker had stolen the data or not. Mary quickly started searching the CloudTrail logs and found the user identity that was abused by the attacker to perform the deletion. Unfortunately, that user had been provided with all S3 permissions, even though a subset would probably have worked. Wanting to contain the attacker's access as quickly as possible, Mary rotated the access keys of the compromised IAM user. She also set about reducing the S3 permissions for that user, while making a note for a more thorough permission audit in the future. After a few more CloudTrail checks to ensure the attacker had not performed any other actions, Mary turned her head to recovery. She knew how important this data was for the successful operation of the company, especially towards their holiday rush period at the end of the year. So, Mary recreated the deleted bucket. Thankfully, she was able to regain the globally unique S3 name and set about restoring the data from her replicated backups. Finally, after a check that everything was working, she informed Nikki that the lists could now be checked for a second time. Okay, once again, this was an amalgamation. In reality, it would sometimes take months for the data loss to be detected. Sometimes the deleted bucket names might be used by another AWS customer before they could be reclaimed. And unfortunately, in some cases, there were no data backups to recover from. Again, before looking at some of the controls that can help, let's have a look at 3 key commonalities with these events. Firstly, the Amazon S3 object and bucket, or buckets, were all deleted, including all versions if versioning was enabled. Second, valid IAM credentials were used. These were normally obtained either through inappropriate storage, think public source code repositories, or from incorrectly secured web applications that allowed the attacker to obtain the credentials. Thirdly, more often than not, no data was actually taken. It was the threat of data loss that was used for the ransom. However, once again, that wasn't always the case. So, again, how do we try and prevent this situation from happening? And there are many ways, but here are 3 good options. If you are able to, consider using S3 Object Lock and MFA Delete. Object Lock will prevent users from changing objects for a fixed period of time, so use it carefully. MFA Delete stops the actual deletion of objects from within a bucket unless you're using multi-factor authentication. This means that when a delete is performed, the object is not actually deleted, but the current version becomes a delete marker. This makes the object look like it has been deleted when accessed normally, but all of the previous versions are still there, at least until they're deleted using multi-factor authentication. Another great way to prevent stolen access keys from being used to delete S3 objects is not to use access keys in the first place. Instead, use an IAM role to give access to S3 objects. Roles can be given to the resources that will be accessing S3, and those resources then use that role to access the objects. There are no long-lived access keys for the attacker to steal. And finally, limiting the permissions that are given to whatever is accessing S3 will limit what actions can actually be performed if an attacker does gain access. For example, does your web server that stores data in S3 really need permissions to delete an entire S3 bucket? Using granular permissions really helps limit the damage if or when things go wrong. Okay, a couple of quick Amazon S3 console screenshots. Object Lock can only be enabled on bucket creation, unless you contact support. But turning it on is as easy as checking a radio button in the advanced settings. However, a second step is required to ensure that the bucket retention period has been set correctly. Just keep in mind that in governance mode, objects can be overwritten or deleted by some users. However, in compliance mode, you need to close the entire AWS account to delete the objects. It's a very powerful tool, so use it carefully. Bucket versioning is easy to turn on by clicking the Edit button, and is actually needed for both Object Lock and another control we'll discuss in a moment, replication. However, for MFA Delete, you will need to use the AWS CLI or SDK. On to detective controls. An Amazon Guard duty is a fantastic tool to help detect unexpected activity in your AWS account, including in S3 with S3 protection. And for accounts created since the 31st of July 2020, S3 protection is automatically enabled with guard duty. So if your account predates that, it's worth checking that you have S3 protection enabled for your guard duty setup. And don't forget to make sure someone is monitoring and investigating those alerts. Another great way to detect unwanted changes to Amazon S3 is to use AWS config with the S3 managed rules. One good rule that relates to replication is S3 bucket replication enabled to make sure that you have a second copy of your data. And finally, setting up a CloudTrail trail to capture both the management events but also the S3 data events can help. It would have helped Mary know if the attacker actually stole any data. And when combined with monitoring for unexpected or risky API calls, it can provide a good source of unwanted event detections. Which events and how many of them are considered risky will of course depend on your organization. Here, you can see guard duty did not have S3 protection enabled in my account. Thankfully, turning it on is as easy as clicking a button. Finally, we come to the controls that can help us respond to and recover from these events. First, we have CloudTrail with those S3 data events. This will allow you to see the exact API calls that the attacker made. The S3 data events are what allows you to see if the attacker performed any GET object calls to actually download the objects. As I mentioned, Amazon S3 replication is an automated copy process that will duplicate your S3 objects to another bucket for easy recovery. Just make sure to check those S3 permissions are correct. And in public preview now is AWS Backup for Amazon S3. This will let you create a single central backup policy for your data in S3 and RDS and a bunch of other AWS services. Okay, our last screenshot, and it's back to the S3 console. Setting up a replication rule has a number of options, but both the source and destination buckets both need to have versioning enabled. Thankfully, there's an easy button to enable that. So, we've talked about AWS CIRT and what that team does. We've had a look at the ransom problem and data protection on AWS. And we have walked through two of the more common ransom scenarios that we see in AWS CIRT, Database-Ransom and Amazon S3 ransom, along with controls to help prevent, detect, and respond to those events. Now, it's everyone's favorite time, homework time. And you have 5 homework items that I want you to do. There are 2 for databases, 2 for Amazon S3 storage, and 1 to bring everything together. First, check that you have AWS config monitoring for public databases, or open security groups if you're self-hosting a database. Would you be able to detect a database if it was made public? Second, check that you can restore from your database backups. There is no point in a backup if you can't use it. Third, check that you have S3 protection enabled in your guard duty setup. And if you haven't got guard duty set up, go and have a look at that. Fourth, check that your S3 data replication and access permissions are working and won't let the attacker delete the replicated copy of your data. And fifth and finally, run a security incident response simulation to test your playbooks, procedures, and communication paths. Ideally, these should be run at least annually and test a variety of scenarios, but for this homework, I'll settle for just testing these 2 scenarios. But if you want extra credit for your homework, then check out AWS Skill Builder with over 500 free courses, and then put your knowledge to the test with AWS certifications. So with that, please do reach out if you have any questions. And please remember to fill out the session survey for this session. We love our data at AWS. And if you've made it this far, thank you very much for watching this session on real-world ransom attacks in AWS and how to mitigate them.